you know, concentrating on the multi-sim part, which is again from National Instruments. Before I begin the session, I would request all the participants to mute their microphones, and please avoid, coming online until and unless it is really required. I request all the participants to kindly mute your microphones so that we don't get disturbed. And thank you all in advance for keeping your microphone muted till the end of the session. Anyways, we'll start with the session. So before we begin the session, I would like to, play a video so that you get the feel of what is automation all about and what industry is wanting as far as the automation is concerned. Before I continue playing the video, are you guys able to see the video?
Yeah.
Bhaskar, check the audio.
Sir? Is it away? Tell me, sir. Is the audio, are you able to hear the audio for the video that I'm playing?
No, sir.
Can you hear?
No.
Yes, sir.
No.
Now?
I see. Manager is using a method of finding the right point.
Irrespective of whether you wish to produce and pack chocolate bars, fill bottles, or palletize yogurt for transportation, with Bosch Rexroth, the drive and control company, it's practically child's play. Why? Because it's at home in your branch as you are. Our optimized drive and control solutions will provide you with continuous and versatile automation. An example of chocolate bar production will demonstrate to you the advantages of precisely aligned electrical, pneumatic, and mechanical drive technologies available from Rexroth, and see how productivity in your individual application can be boosted with increased clock rates, faster format changes, and higher product quality. Competence in total line automation. Starting with the making raw chocolate mixture, provides constantly high chocolate quality. At the start of the process, the ingredients are continually fed to the mixer by way of speed-regulated drives for auger filling. Easy to clean, hygienic pneumatic cylinders are used to batch the ingredients to precisely match the recipe. Finally, high-performance Rexroth drives ensure the chocolate raw mixture is always homogeneous, both in the mixer and emulsifier. Electrically driven transform the mixture to the crunching process. Here too, Rexroth drives are guarantors of a constantly high product quality.
ఎవరు నాదా నెట్ డిస్కనెక్ట్ అవ్వదా
Innovative automation concepts with digital servo drives, corrosion-resistant pneumatic cylinders and valves, as well as hygiene-compatible linear modules, ensure high-precision chocolate molding. Here, the intelligent control technology coordinates all movement processes. After the cooling process, highly dynamic linear motors decorate the bars to perfection in accordance with individual requirements. After yet another cooling process, the electrical control and drive technology takes over the high-speed sorting of the chocolate bars. The result is precise, exact, uniform product spacing, the downstream packaging process, low wrapping. Here, the continuous synchronization of product and package serve to provide perfect longitudinal and cross-sealing, thus subsequently an ideal presentation of the chocolate bar at the point of sale. Carton makes high demands on dynamics and accuracy. Rexroth guarantees increased clock rates through a perfect combination of electronics and pneumatics. The electrical drive and control technology synchronizes the magic belt and coordinates a protective infeed of the products into the secondary packaging process. All conveyor tasks related to the packaging process are mastered perfectly by the modular Rexroth chain conveyor system. It can be individually adapted to meet your product requirements, and because of its variables, it's suitable for both horizontal and vertical product transport. While pneumatic grippers make sure that the blanks of cartons are handled carefully, the intelligent servo drive technology and ready-to-install linear motion systems erect the cartons. Fast SCARA robots made by Rexroth with high-performance control, standard program interface, and integrated image processing serve to make product handling more versatile during case packing. Reliable, fast palletizing with gantry robots is an ideal example of our efficient automation solutions, economic from project planning to production. Integrated robotic functions into the control shorten both the project planning and startup times. Safety fences made up from our modular aluminium profile construction kits are easy to handle. Maximum protection for people working at the machine and on the transport parts. Open motion logic solutions as provided by Rexroth provide greater transparency and efficiency in your production. Field buses standardize the connection to the local control systems of the production control center. Synchronization of the machines and individual units by means of cross-communication enables the modular design of innovative machine concepts to be realized. Networking the systems using Ethernet provides you with central access to all production technology relevant data. You can count on our comprehensive technology solutions with best-in-class components and our local specialist teams around the world. Rexroth, competence in total line automation.
Now, I can enjoy the chocolate. Here, packaging now for the starting. Of course, collaborate with company partners.
Okay, that was a small video about 6 to 8 minutes. That was a small video about, it was about 6 to 8 minutes on the automation. It was basically concentrating on the, chocolate manufacturing and packaging industry. So I think you got some feel about how basically industries deal with this automation. Why this automation is really required. Why this automation is really required in industries. And, every day lots and lots of production is going to happen, and things needs to be very precise. So in that case, if there is a lot of human intervention, obviously humans are more prone to noise. They commit a lot of mistakes. So in that case, obviously, a large production will have a kind of setback if too much of human intervention is there. So automation is always kind of required. So today's topic, what we are intending to discuss, is solely on that. So the title of this today's session of I thought of having it this way: National Instrument Multisim and the World of Automation. So what does this Multisim got to do with the automation? Automation is totally a different scenario, and Multisim is basically multiple simulator where you try to simulate some circuits which are either electrical, kind of mechanical, kind of electronics kind of thing. So these things are how basically these things are related to automation. Is a big question mark. So just felt that instead of taking Multisim as a whole and try to bring in this the Multisim basics to the whole audience, I felt that giving the essence of automation with the Multisim would be a better, because you'll be able to concentrate on one particular, the most important part of industry, which is automation. So if we are able to get a feel of Multisim with automation, I felt that it is good. So keeping that, so we are going to have this kind of discussion for today's session. So just to start with this whole session on Multisim with automation, I just wanted to highlight few things about, again, what are the things that we saw in that entire video that we saw. So in that video, we were able to see few things like kind of, let me list out all those. I love to do it because before we get into this automation with Multisim, we will be able to understand these things. So there's a kind of precision required all the time. So we would require precision, which is always required for automation. Then we would require kind of for achieving this automation, what and all is required. So let's say the video which I played was kind of a chocolate manufacturing industry, where chocolates were kind of molded, they were cut in the proper shape, and they were put in the they were kind of packets were made and they were put in the container, and finally they were all palletized. So in the process of automation, automation, you would be wanting to basically cut. In our example that in the video that we played, you would be interested in cutting the chocolate precisely. Then you would be interested in having 5 chocolates put in one container, etc. Then taking these 5 set of chocolates and putting it to one single box, let's say a single box containing 20 sets of 5 chocolates, and then in the process of doing all these things, we need to all the time maintain a kind of let's say a gap. First 5 chocolates coming on a container like this, and that you guys saw in the video. So probably may require a little bit of is my voice breaking? Am I audible to all of you? Am I audible to all of you?
It's breaking, sir.
Okay. But many are saying that I'm audible to all of them. So there is network issues, I believe. So what I was trying to highlight here was the different processes that are involved. So you need to maintain a gap in between. So there's a kind of proper timing that is required. So there's a timing as well required. Some roughly trying to list out the things that we may require in the process of automation. So when you look into all these list of things that are put, very simple list of things that we have put. So in simple words, that is not visible properly. So in simple way, I can just say be interested in timing. You would be interested in kind of counting, and you would be interested in keeping all these things intact, like a proper, let's say a proper control of the entire process. So all these things we are basically supposed to do in simple way in the process of automating any production unit. So now the thing is getting to know that what an automation involves in it. Kind of timing is required, counting is required. The entire process needs to be controlled in the right way. So a lot of logic is all the time involved in doing all these things. So having said all these things, now I think we need to get into the actual automation.
సార్ ఇప్పుడు వాళ్ళకి మన అటెండెన్స్ ఇవ్వాలి కదా అందుకని సార్ అదేం లేదు లేకపోతే
Now we need to get into the actual automation thing. So where we will understand how automation is really achieved. So to again get to know how automation is, how the kind of industries were operating earlier. So I would like to again show you one more small presentation where you will get to know how it was earlier and how it is now. Are you guys able to see this? And one more reason behind putting that particular video, Bosch Rexroth, is we are kind of we have an MOU with the Bosch Rexroth, and we have a state of the art center of excellence lab setup in our campus, and we do provide internship programs. We do provide kind of training programs for students and company people as well. So this is a small history about the PLC. Now all of a sudden we have got into PLC. I don't know how many of you really know about PLC. PLC is basically a programmable logic controller. Okay. So a programmable logic controller is basically a industry machine which is used to automate the entire process. Shortly you will get to know what is the PLC all about. So in earlier days when they were doing the automation, what they were doing was they were using a lot of kind of relays, switches to switch on and switch off. As you saw the video earlier, there were a lot of machines that were involved, probably mixing conveyor belts and moving the chocolate boxes from one point to another point. So a lot of things, a lot of mechanical stuff were involved. So to control all these mechanical or machines, you always require a lot of switches. So in earlier days, all these were done using basic relays or switches. So thousands and thousands of relays and switches were used. So, and if at all anything goes wrong in the middle, somewhere in the middle, any switch goes wrong, the debugging of all these things would have become very difficult. So keeping that in mind, what people thought was to bring in the concept of PLC, Programmable Logic Control. So in the earlier days, that was a scenario where we were using thousands and thousands of relays and switches. So now the concept of PLC has come into picture. So the PLC is basically as a kind of computer, I can say, which controls industrial machines and processes. And in different areas of industry, PLC are basically being applied. Like in case of handling what I can say materials, kind of packaging, palletizing, kind of milling, boring, grinding, filling, sorting. You take any kind of operation that happens in industry, everywhere this PLC is basically used. With logical relays. Now, what is a relay? Relay is basically a combination of a coil and a contact. All of us know, and how it works is also known to us. Now, what you can observe here on this side, it is the one which is shaded with blue. There is basically the relay where you have a coil and you also have a switch. So when the coil gets energized, the switch is going to get closed, and you say that the current will flow. And that is how basically a simple electromagnetic switch or relay is going to work. So this is kind of depicting how basically a relay is working. So whenever a coil gets energized, the magnetic field will be kind of reduced, and the contact will be pulled towards it. And you can see that there is a make in the contact, and the current will flow in the contact as well. So the entire PLC, the programmable logic controller, is based on this concept of relay. So what a PLC will involve in it is basically relay, that's it, nothing else. And it is just a simple I/O box. So between the input and output, what it has got is number of switches in it. Okay. So I think this much is enough for us to understand what is a programmable logic controller. So in simple words, to make you understand what is a PLC, I can just say it is just a small box which contains logical relays. You do not have a physical relay, and that makes a difference. So when I say there are thousands and thousands of physical relays, maintaining them, kind of if at all anything goes wrong in between, maintaining that becomes a difficulty. So in case of PLC, what we have is all kind of logical relays. You physically don't see a relay, but you say that there is a relay inside it. And lakhs together of relays are, we are able to realize using a programmable logic controller. The name itself says. So the controller is basically logical in nature, and you write program to control those basically the entire operations, whatever happens. So that is basically a PLC. So I hope you got this point of what is PLC. Any question at this point? Any question about what is a PLC and kind of stuff? Okay, good. Thank you. So having said that, now we'll get into the PLC now. The multisim part. Now that basic knowledge of PLC is required because in multisim we will be doing something called as a ladder program. So, and ladder programming is the kind of programming that we use to build the logics for PLC. Now let's get back to this job of getting to know what is multisim and what is the difference between Labview and Multisim. If somebody asks what is basically the difference between Labview and the Multisim, the core difference between Labview and Multisim is Labview is going to give you the front end part, and Multisim is going to do it's going to do the job that you want it to be done. Kind of all kind of circuit operations can be done using Multisim. So basically, Multisim is a basic virtual EDA, which is electronic design automation software, and the name itself says automation can always be achieved using Multisim. And Labview is pretty way of presenting the results graphically to the end user, which basically introduces isolation of user from the backend circuit and the user level abstraction. So backend becomes Multisim. If at all you're talking about Labview and Multisim, Multisim is going to become the backend, and Labview will become the front end. So it's kind of the user interface for this. So that's the sole difference between a Labview and Multisim. And all the time these two can be communicated to each other. In the sense, you can all the time interact with Labview as well as Multisim. So do something in Multisim and try to bring it to Labview is possible. And do something with Labview and give it to Multisim is also possible. So two-way communication is always possible with Labview as well as Multisim until and unless you take care of things properly. So I assume that all of you have installed Multisim on your laptop or computer. Assuming that all of you have this 14.xx.x, so 14.123, any version is fine. Assuming that all of you have this Multisim, I would want you people to please open the Multisim. So please double click on Multisim and open it, and see to it that you have this window. See to it that all of you are able to see this window. Yeah, all of you can see this window. Yeah. So in this window, what you observe is these things. Let me put that.
Being a wonderful audience, started with the season 1 on technology, season 2 on. We are completing season 4 on the future of education. So we will thank every participant because you have been a wonderful audience, and specifically the educators.
So I just open that Multisim. What you will observe,
నా మొబైల్ తీసుకురావా, అది నా మొబైల్ కావాలి, అది ఇంకొక వర్క్షాప్ ఉంది కదా, అది ఆన్ చేసి పెట్టాను.
This is the window what you are able to see, and this is where you basically will be writing the circuit diagram or kind of the circuit which you want to simulate, and you have toolbars right here, and this is where the design toolbox is there, which will show or list out all the designs that you do next. And these things are kind of known to all of us. You can all the time understand what these are, just to give you a feel of what are there. And this is most important thing, the component toolbar is right here, which will give you things like components, basic components or basic elements, kind of all different kinds of ICs and all, which you will get to know shortly. And that is where basically all the components, few basic components are available. And these are the two things, two buttons which are used to run and stop the filtration. And this is also kind of instrument toolbar where you can find function generators. This is on to the right side. So if you see the Multisim screen to the right side, you can see all these things where you can find multimeter, function generator, and other things. So these few things are anyways we will do it. I just wanted to show you quickly as to what this entire window looks like and what they are. Okay. So what we'll do is quickly to simulate one circuit, one simple circuit. My idea here is not to start do many things on the circuit part. but to do something on the ladder programming part. So I will be using one or two simple circuits to show how basically multisim can be used for simulating any kind of circuit. Okay. So this is a multisim. Now let's say I want to simulate a small circuit, let's say a simple voltage divider network. So what will you do? You will go to place basics. If you can see the component toolbar right here, you can go to place basics, and what and all are required to do a simple circuit of voltage divider. Probably we may require 2 to 3 circuits. Let me try to simulate a small circuit now. I'll be interested in inserting 3 resistors. If you click on this place basic, I hope all of you are tuning with me. So you can see resistor there. So you can choose any resistor of your choice. Let us say 1K. One K. And third resistance. I'm really not worried about the kind of output that I get, but I just want to get all of you a feel of how to use multisim for rigging up circuits. Now this is a very damn simple circuit what we are doing. So once all these 3 resistors are placed, probably I can take one more resistor to have output across that. So let's say one more 1K. So I have placed 4 1K resistors. I hope all of you have done the same thing. You can use any resistor, any component of your choice, but I have placed 4 resistors right here. So once that is done, you can think of using a supply. Let's say I'm going to use a DC supply. I'm going to use a DC supply. Where do you see DC supply? If you go to sources, you will be able to see under power supply DC power. I'll place a DC power supply. You would be interested in having the ground as well there. I'll use the ground. Anything else is required? As of now, I think these are more than enough for me. So I'm going to arrange all these things in the right way. So I'll say 1K resistor there, one more resistor here, one more resistor somewhere in the middle. So if you want to rotate that, you can right click on that and it will give you rotate clockwise or anti-clockwise. You can do whatever you want. Just right click on the component. You'll be able to do whatever you want. And one more thing. Right. Now if you want to alter the values of these resistors, you can double click on the value. Double click on the individual value. And you will be able to make the changes for that. So let's say I want this is 2.2K. I want this resistance as 2.2K. And just let me the system as I'll have this resistance as 5K. Let this be 10K resistance. So any value of your choice. Now you need to do the connection. So you need to interconnect all these things. I'll start from the supply side. I'll just click on the tip of the particular component. The moment I click on the tip, or if I bring my cursor towards the tip, it will show me the wiring connection. You can just drag it and drop that particular wiring wherever you want. And likewise, go to the other side, click on that edge or tip, and connect the ground. And likewise, do all the other connections. I hope all of you are able to do it. So we are done with the connection part. A simple resistive circuit is rigged up now. Now I would be interested in measuring the input voltage as well as output voltage. So what I can do, we can go to the right side. The right side of the window, you can see many components or any kind of equipment placed, and I will choose multimeter out of it. So the very first component or equipment what you see is a multimeter bar. So I'll take a multimeter, click on that and place it here. Here you can measure current, voltage, you can measure resistance, you can measure the power as well in dB. So I'll be interested in measuring the voltage. So I'll connect the positive to this point and negative to the other side. I'm done with it. If you want to measure the input as well, you can do it, but right now we may not require because I know the voltage is already 12 volts. So I may not require a multimeter at the input side. Now we can run this. We can run this simple simulation. To run it, we're going to use this play button. This is there exactly above the circuit. So in the last row of the toolbar, you can see a run, or I can press F5. Both will run the program. To run it, and double click on the multimeter to see what is the voltage that draws a 10K resistor. This is the voltage that it gets. 2.39 volts. This voltage what you are getting. Okay. So this is how we basically do the simulation part, and the same circuit can also be taken to the Labview as well. And probably I think this is not the right platform to understand all those things because as we need to move ahead to the ladder programming part. Okay. So I think this much of introduction is enough for all of us to understand how we can rig up circuits using Multisim. Okay. And you can find all different components. You can stop this and you can try to discover the different components that are there in Multisim. So almost 17,000 different components are available in Multisim. 17,000 different components, and you can have your own component as well designed. So if at all you want a particular transistor of so and so configuration, that is also possible with Multisim. So a lot of things could be done. It's a kind of very user friendly and a kind of versatile. Everything could be done with this Multisim. So having said that, now what we can do is we'll quickly try to get into the ladder part of it, ladder diagram part. So again, I would like to share the whiteboard before we start inserting the ladder or writing the ladder logic here. So what I can do is I can just create one more design. Let's say a new design and keep it empty for the time being. The time being can keep this empty so that once we complete understanding how and what is ladder diagram and how to write it, we can come back here and start inserting all those things what we learned, what we're going to learn in the coming discussion. I'm sharing the whiteboard now. I'll just try to explain a few basic things about ladder diagram. Then we should. So before I explain what is ladder logic and all these things, I would like to take one example here. Let's say I have a small job to be done. There is a lamp, let's say, has to go on. The moment I put on the switch, let's say I have a switch S, this is a lamp, a small job that needs to be done. So what it is doing, the moment I turn on the switch, the lamp should glow. What is the job? So this is basically for understanding this diagram is fine. But when you try to write this as an electrical circuit, how will you write it? How is that you are going to write it? So you would obviously require a supply. Because without a supply, even if you have a switch or a lamp will not glow, even if the switch is placed. So let's say we are going to have a supply of 24 volts, and there is a point behind taking this 24 volts, which I'll tell you shortly. Then you have a switch, then you have the lamp. Let's say this is a lamp, and that's an output for it. So what you are doing, you are giving an input, and you are expecting the output from the circuit. These two things you are doing. And input is, even though you have a supply, input is given by the switch, which you will again understand now. Now this becomes an electrical diagram. Now in the same particular example that I have taken here, if you want to implement using a ladder diagram or ladder program, you need to understand few terminologies which are used in ladder program, and you will also understand why we are calling it as a ladder program. Okay. So what we may require will be a contact, that is this, which I have called it as S. You would require a supply, which is of 24 volts, and anyways any circuit will also have a ground. That's pretty important. Any circuit will also have a ground. That is the known thing. The supply, when I say, it includes 24 volts as well as 0 volts, and it requires an output, which is lamp in electrics. I have written it as a lamp. So in writing the ladder program, you need to identify these things. What and all are required. So in my simple job, where I want to switch on the lamp using the switch and using a supply of 24 volts, I would just require a single contact, yes, and I would require a supply which is 24 volts as well as 0 volts, which is indicating ground, and an output which is lamp. Now when I am saying contact, what kind of contact am I taking? So normally, under normal circumstances, in normal condition, the position or the status of the switch is open. Until and unless you don't operate on that, the status of the switch is open, which you call it as a normally open contact, NO. So which means it's normally open contact. So if there is a switch which is normally open, there should also be a switch which is normally closed. So a normally open contact is normally indicated like this. This is a normally open contact. How would you indicate a normally closed contact? A normally closed contact is indicated like this. This is how a normally closed contact is indicated. Now these are in the electrical sense. When you try to write the electrical diagram, these are the representations that we will use. But when it comes to ladder programming, there is a small change in the indication that we do. A normally open contact in ladder diagram or in ladder programming, you want to indicate it like this. Just as good as a simple path plate capacitor. So this is how a normally open contact is indicated. And a normally closed contact is indicated like this. This is a normally closed contact. So I hope till here things are clear. Yes? Can you proceed?
We'll cover this in the next session. You have the slides which
go ahead.
Just take a minute to read it.
Is it not clear? May I know what are the questions that you have got?
Okay. So you know that there is a word called as reverse Indian, and you know there is a word called as Indian pharma industry.
Okay.
Reverse engineering.
If there is any question asked, please let me know. Now we are actually getting into the groove of multisim with automating.
Before this was agreed upon.
Initially we had discussed about the PLC part. Probably most of you may not be clear with that. Anyways, you will get to know once I start doing the ladder programming, you will have the feel of the PLC as well as automation. So not to worry. But right now, just try to understand what is done here. So probably these are the important things that you would require in understanding the automation process as far as usage of PLC is concerned in industries. So let's stick on to these two notations now. Normally open as well as normally closed. Further to it, you may as well require an output. An output is normally indicated as a file in case of ladder diagram. An output is all the time indicated as a file in case of ladder program. And how a file is indicated? You normally indicate it either this way or it is indicated like this. It's one and the same. Okay? So this is how an output is indicated. So now we'll try to write the ladder program. So
The 1970s Indian Patent Act allowed the new person called Harita
what I'll be doing is,
for that. Are you able to connect?
I'll say on one side, anyway, we'll start with the basic level of writing the ladder program. I'll be writing two lines here. Just above the line, let's say it's going to indicate 24 because I want 24 volt supply. I'll be deriving 24 volt supply points. And below line, I'll say it is 0 volts. Now 24 volts, between 24 volts and 0 volts, if you can see the circuit diagram, between 24 volts, that is this point, and 0 volts, which is this part, there are two components which are sitting. One is the switch, other one is a lamp. So what I will say here while writing it, I will say I'm going to insert a switch like this, and I'm going to insert a lamp like this. Same circuit, written in slightly different way. Somebody is asking why particular 24 volts, and there is a reason behind it. All the industry applications, as far as the PLC is concerned, as far as all the PLCs are concerned, there are so many PLC manufacturing industries. One main competitor is Bosch. So when all these different manufacturers manufacture this PLC, they all stick on to one standard rating, which is 24 volts. So all industries except this 24 volts, and that's the reason behind taking 24 volts. Somebody started with 24 volts, people started accepting this. So this is as per IEC standards. So as per IEC standards, all the PLC manufacturers would prefer 24 volts as a supply, and that's the reason behind 24 volts. There is absolutely no other way. Okay. Is that fine? So let's come back to this. So what I've written here is it is a constant voltage for PLC manufacturing machines. So when I say 24 volts will be used by input as well as output. Again, you will shortly get to know why this 24 volts. When you are trying to operate the PLC would require 230 volts, 50 Hz or 60 Hz, whatever it is. But when it comes to internal to the PLC, how basically these input and outputs are being used in the logic, the logic would require 24 volts, that's all. So it is the logic which is using this 24 volts, and based on whether it is a 24 volts or 0 volts, the logic is going to operate, or the relays are going to operate, I can say. But again, once I complete this Labview program, I'll tell you where the 24 volts is utilized. The PLC would require 230 volts and 50 hertz, but when it comes inside to it, we're going to use 24 volts. Basically, 230 gets converted to 24 volts. So, what I was saying, I was just saying that you will have a switch, yes, here, and a lamp. Now, the screen is shared, madam. Are you able to see the screen? Somebody is asking to share the screen.
Yes, sir.
Okay. So now what I'll do is I'll try to tilt it 90-degree anti-clockwise. I'm going to tilt this diagram that I've written 90-degree anti-clockwise. So what you will see is basically 24 volts to this side and 0 volts to the other side, and you will have the switch like this, S, and you will have from the top, sir, from the top I cannot put because I'm scrolling it down. So sharing the screen from the top is quite difficult. I can do this way. I can show you the upper part and I can scroll down later on. Just a second.
You will.
I'm extremely sorry. I was not knowing that my screen. You're not able to view my screen afterward. After this NO and NC. I'm so sorry. Probably we can redo this. I'll redo whatever I wrote. So I hope all of you have noted this. In the sense, you remember what I've written here. So because you may require it for the next this thing. So I'll erase all these things. I'll start with the previous part. So my job was this. I'll just write only that electrical circuit. Okay. So I have a switch. I have a lamp. Here's the hand. And okay, right. So I'll say 24 volts above, 24 volts below, and I'll be just inserting the switch as well as the lamp. Now what I'll be doing is, this diagram, these two are kind of identical. There is absolutely no difference between these. Now the reason behind writing this particular circuit or this diagram or representation is to bring this representation of electrical diagram into the ladder diagram. So when I write it this way, it will be easy for me to show how to write the ladder diagram. So it's just a kind of intermediate representation of the circuit which you are taking. So when you tilt this anti-clockwise by 90 degree, tilt this particular diagram by anti-clockwise 90, you'll be able to write this is 24, this is 0 volts, and in between you have a switch and a lamp. Now we are almost 90% through with the ladder diagram, but a ladder program works only when to write things in its way. In the sense, the representation to be proper. And I told how NC and O's are returned or represented in case of ladder. So normally close is always written like this, two parallel plates kind of thing, and a negate in between. And NO is always indicated by two parallel plates like this. And an output is always indicated like a oil in this way. Or you can write it as a circuit. Anyways, it's fine. So what I'll do now is I'll try to write further, which is the last step for me, like this. My first thing will be what kind of switch? A normally open switch. This side will be 24 volts, and the other side will be a simple lamp for me. Now this is what is basically a ladder. Now why is it called a ladder? If you can see this, it's basically looking like a rung. Rung in a sense, you know, the crossway, you know, wooden piece of a ladder. This is what is called as a rung. If you see a simple ladder, you will have a lot of rungs, and that makes you know, the whole ladder. So that's the reason why you call it as a ladder program. So what we'll do is we'll take this simple example and try to simulate it in Multisim and understand how we can visualize things. Okay. So let's quickly go to Multisim. So I'll stop this sharing this white screen and go to Multisim. Now all of you are on the screen now. You are able to see the Multisim content, the window. Okay.
Sir.
Yes, sir. Okay. Now, if you can see the topmost row of the toolbar, you can see a place menu there. So go to place menu and go to the last option, the last item of the list, which is place ladder rungs. You can do it two ways. You can all the time go to place and go to that place ladder run, or you can right click here in the toolbar and select this ladder diagram. I'll tell you, you can either go to place and select this all the time, or if you want it, you know, to access easily, you can right click on the toolbar and you can select this ladder diagram. In my case, it's already ticked. So if it is unticked, please tick it so that you can always see the ladder right here. You can see this ladder rung now here. You can see place ladder rungs and place ladder diagram. So right now I'll be interested in placing the ladder rung. So in our example that we took, we require only one single ladder rung. So I'll click on this. Now you can see two things appearing on the either side, which are two vertical lines that I indicated there. You can place it there. You can place as many rungs as you want. So in my case, or in our example, only one rung is enough. Now if you double click on this side, yeah, so we are done with it. So we are kind of, you know, place the ladder rung. Now our next job will be to place a contact as well as an output lamp. So I want to see once the contact is closed, the lamp should glow. So I am interested in placing the switch as well as either a coil or in my case a lamp. Anything will do. So I will go to place ladder diagram. Just before to, you know, ladder rung, you have got ladder diagram. So place ladder diagram. Select that. This window will pop out, and in that window go to ladder contacts. Now there are four different contacts in it. One is input contact NC, input contact NO, relay contact NC and relay contact NO. Do not choose the relay part, choose the input contact part. Now what kind of contact are we interested in? We are interested in normally open contact. So choose a normally open contact. And if you can see, this is exactly identical to what we wrote there. And at the same time, you would be interested in placing a lamp. So what you can do is, if you do not know where to check or find the lamp, you can just directly type lamp here, go to all groups. Now these are the different families of groups that you have got. Sources, basics, diodes, transistors, unlock, ATF, many things are there. Even the ladder diagram is also a part of the group. So you can select all groups and you can just type lamp, or you can search for indicator and search for indicator. Let me type it as lamp. Do this. You can see indicators right here. Under all groups, you can see an indicator. So I'm going to place, let's say, 28 volts, 7.5. I'm going to place this. We are done with it. Now we can run this. Now things are ready. This is what we wanted. Switch on the, turn on the switch and the lamp should glow. We have turned on the switch. Absolutely nothing is happening. I have turned on the switch. Absolutely nothing is happening. Did I really turn on the switch? I just ran the program, but switch is still not turned on. So we need to turn on the switch. So to turn on the switch, a small thing needs to be done in this multisim. When you are provided by other PLC manufacturers, there things will be different. But in multisim, you need to put one more thing before you run the program, and that is this. Again, go to the ladder program, place ladder diagram. There you can see ladder IO programs. I hope all of you are able to see that. Yes, I know all of you are doing this along with me. So go to ladder IO modules, then place ladder diagram, go to ladder IO modules, and you can place any module of your choice. So right now we will take input module 24 volts, and if you can observe here, there are so many modules, and 24 is also mentioned, because as we are doing simulation, you can use any volts and try to simulate it. But all standard PLC manufacturers will always take 24 volts. So choose a 24 volts and place it here. Now if you can observe something, there's X1, below X1 something is written, 100 space 1. That indicates that you need to require an input module, and the identifier of this is same as identifier of this. 100 for X1 is same as 100 for U1. It indicates there is a reference. There is a reference designated for U1 as well as this switch. So you should be using a input module to input a value to the switch. Otherwise, this switch is not going to work. It is as good as a dummy switch. So this switch will be operated only when you apply something to this particular input module. Now in this X1, the number is 101, indicating that U1 has got 8 different input pins, and in that you are going to apply to the very first IN1 a high signal to operate this switch. You got my point? Did you get my point what I said? 101 for X1 is indicating that 100 is basically the pointing to the input module, and 1 is indicating to the pin of that particular input module. So you should be applying a high to this so that you operate this switch. So what you can do now is you can place directly 24 volts, or you can do like this, which I will show like this. So I'll be showing it like this. So what I'll do is I'll try to place, let me take it from here. I'll be placing a source of, let us say, a DC power supply. And I will also require a ground. Now you know where these are available. I'll leave it to you to please search all these power supplies, grounds and all those things. And I would also be interested in doing one more thing, which is push button in my case. Let's say I want a push button. We can select all family and you'll be able to see this. Select all families, all groups. You can see a normally open and a normally closed. I shall take a normally open. I can do the connections. What is the difference between a switch and a push button? Push button is it is going to retain its state until we keep it pressed. The moment you release it, the state will come back to its original position. So that is. So now we'll try to see whether it works or not. I'll make this 24 volts. The supply is made 24 volts. So let's see whether it works for me or not. Able to see this? I'll do it again. 24 volts. Let me replace this by Now what I can observe is this. The moment I close this push button, you're able to see the lamp glowing. The moment I release it, the lamp will also stop glowing. Now we are able to see the operation that is happening. So switch is being controlled by this input module through a push button right here and with a 24 volts applied here. Now where these rungs what we have inserted here will not have any supply as such in this multisim. It won't have any supply. But when you try to do it in the real sense, these rungs what are placed in the real ladder programming language, you will see all those vertical lines having 24 volts and 0 volts respectively. The whole concept is going to remain the same. There is no change in that. But the only thing is, in the multisim, you are going to place 24 volts. So this is how basically it works. Now what I want to do is, I want to keep this particular lamp on even if I remove this the push button. In the sense, I am keeping it the S1 pressed. Until and unless I keep it pressed, the lamp will be on. The moment I release this switch, the lamp goes off. So I do not want this to happen. I want the lamp to be on for the entire time once this particular switch is pressed and released. So what will you do? We're going to make a small change to this program that we've written. So what we can do is we can insert one more rung here. So I'll stop the simulation. I hope all of you did the simulation till this point. You got the feel of input module now. So what I can do is, for the time being, I'll just keep these away. Lamp. I'll bring in the concept of relay. Now this is where actually okay. You have still not finished. Please finish this up. Once you have finished, let me know. I'll proceed further with the next part. Is it done? Is it done? Once you say you're done, yes, this can show errors that you have done. It is going to show errors that you have done, and it can auto-correct it. Most of the time, this multisim can auto-correct it. That is also there. If you have done some simple mistakes, not adding a, where I get a switch. Okay. Where do you get a switch? You can go to basics, you can open any component as such, just straight away go to all groups and all families. Don't worry about anything. Directly go to all groups and all families, and just in the component here, search in the component search toolbar. The component search toolbar, what you can do is you can just type PB. PB stands for push button. It will show you the list. This list. It will show you the list. This list. And here you are supposed to select either NC or NO. Right now we are interested in normally open. Push button normally open. To select that. I hope this is done. Shall we proceed further? And we move ahead. All of you are done. So now what the problem is, when I press the push button, the lamp was glowing anyway, but the moment I release the push button, the lamp also went off. But I want the lamp to continue to glow, no matter what is going to happen to this push button, whether it is on or off, kind of anything. So how do we basically achieve it? And I told to do this, you're going to bring in the concept of relays, and that is where the actual relay concept is going to come into picture as far as PLCs are concerned. By PLC, basically, we say that it's kind of all logical relays. Relays plays a very major role. And this is one example where you can understand the concept of relays and its importance. I will go to this. I'll go to this ladder diagram. Now I'll go to contacts. I'll go to ladder diagram and I'll go to contacts. Now you're supposed to choose this relay contacts. Now I'll select this relay contact NC, NO. I'll be choosing relay contact NO. And I'll place it here. I'll go to the relay coils. I'll choose a relay coil as well. So please remember, we are doing two things. One is choosing the relay contact, other one is choosing the relay coil. So in ladder contact you can see relay contact NO. In ladder relay coils you will see relay coil. So we are going to choose these two things. I'm going to place it. Now just look at the placement of these two coils as well as the contact. I'll place the coil that I've chosen, which is M1, in the very first line, and I'll make the connections like this. I'll insert one more rung. You say here. You also can do meanwhile. And I'll place this contact right here. I'm placing this contact, which is the relay contact, right here, and I'll place the lamp here. And make sure that the connections are made properly. Otherwise, you won't get any output. I hope this much is done now. I hope this much is done now. Now we will run it. Anyways, it's not going to work the way we want it, but we will run and see what is going to happen. So I'll play this. I'll run the simulation, and I'll press the push button. Now, what are we able to see? We're able to see the lamp glowing up. And now the only change between the previous one and this one is the combination of this oil and the contact has come into picture. If you can observe the names given to it, the contact is having a relay contact is having a name M1. The coil is also having the name as M1, which we call it as reference designator. M1 is basically a kind of reference designator. So you can change to whatever you want. Let's say at 10. Simulator is running. I cannot make the changes. You can rename this and call whatever you want. So yeah, you can make the changes there. Yeah. So right now you have M1 and M1 here. So this coil and contacts are put together. So a combination of this coil and contacts is what is basically a relay. So the entire concept of relay is brought in here. But we are still not able to understand what is the importance of this relay concept or what is coil and contact are doing. Now the point was, when I press the push button, we wanted the lamp to glow. So the lamp was glowing, but I want the lamp to continue to glow even when I release it. So what we'll do is we'll make a small further changes here and try to add one more contact. Is normally open. And try to place it here. So please observe what is being done here. I just brought in this contact. And connected it across X1, which is 101, which is my actual space. Now we will run this and see what is going to happen. We're going to run this and check what really is going to happen. Now I press the push button and I released it. Even after releasing, you can see the lamp glowing. Now what is the change that we got? Now this entire logic that I've written here is what is called as the latching concept, latching logic. So we have latched the input to the output. By making a small change in the entire logic that I've written, I'm able to see the lamp glowing even without this push button being pressed. I pressed it and released it. The lamp continues to glow forever until and unless I don't stop the simulation. Now this is basically what is called as a latching concept. Now this latching concept is the most important concept that we use in automation technology. So whatever we do in automation using this ladder programming, all the time we go for this latching, because everywhere we basically use push buttons and we try to keep doing many things using this push buttons, which are actual inputs. So got the point. Now, is anybody having a question as to how this entire logic is working? Good. No questions. Thank you. Okay, do you want me to repeat this once? Okay. So what was happening earlier? Okay, let me remove this switch for the time being. So what was happening earlier? When I pressed the push button, what was happening? IN1 was giving a signal to this X1, and X1 would get closed. The moment X1 closes, 24 volts will flow to this M1, which is a coil, that will get energized. And there is a coil contact relevant to this M1, which is this X3. So once the coil M1 gets energized, the contact will also be closed, because a normally open becomes it becomes a closed contact now, because the coil got energized. So the moment this contact closes, the lamp will close. So this was happening when you had kept the push button in the rest position or in the close position. But we wanted the lamp to continue to glow even when it is getting released. So in that case, what we did was we provided a separate bar. From the input side. So once the 24 volts get applied to this particular line, once 24 volts gets applied to this line, this contact what you see or what you had connected across X1 will provide a separate path for this M1 to be in the energized state, and that M1 coil will keep the M1 contact to be in the energized state, and that makes the lamp to continue to flow. This is what we actually did. I'll bring in that no contact and place it here. I'll connect it like this. Now the moment I press it, you can see X1 as well as X4 both goes green. When both are going green, the moment I release this push button, I'm still keeping the push button in the on condition. The moment I release this, X1 will go off, but X4 continues to be in the green. You can observe that. X1 became black, but X4 is still in the green condition, which means that it is still in the high state. And who gave that high state? This M1 coil gave the high state. This M1 coil, what you have here, as it got energized, it will try to close all the contacts relevant to that coil. So there are two contacts that we are using relevant to this particular coil, and that made the lamp to go to high. So this is how the entire latching concept is going to work. I hope it is clear. Thank you. So after having said this, what we can do is we can slightly move ahead and try to understand or get to know how we can switch off this. Now I want to switch this off. How do I do it? I don't have any means to switch it off. Now the lamp got on, but I want to switch it off. The only control that I had was the S1 push button. Now immaterial of what I do with this, nothing is happening. I'm not able to see anything happening. So I want to improve this logic. I want to insert something to which I'm able to switch this particular lamp off. So in that case, what I can do is I can just bring in one more contact. Where? So I can place, let's say, a normally closed one this time. Just observe the logic behind this. I'm placing a normally closed now. I'll try to have this number. Now if you want to change this number, you have got this contact as 101. Let's say I'm going to give the input to this particular switch from IN2. So what you can do is you can double click on this and write it as 102. And I'll use the same components, or I can directly take this 24 volt from here. I can directly take this 24 volts, and I can use a push button. Let me place that here. Calling it as S2. I'll take same 24 volts and I'll give this to IN2 now. Why it is IN2? Because X5 is going to operate based on what you apply to IN2. Okay. So now what you can do is you can operate this and see what is going to happen. So remember, when this push button is not pressed, S2 push button is not pressed, X5 will be in the closed state. The moment you operate on this S2 push button, X5 state will change, and that alters the whole state of the circuit operation. So we will see now. And remember, I'm not going to do anything with this S2 push button. I'm going to press. I've started the simulation. I have pressed it. Things are all okay as usual, as we did in the previous part. But the moment I press this S2 push button, just observe what will happen. The lamp got shut. So the lamp is off. Because there's normally closed switch. Given the current to flow through this particular path all the time until it will not operate on this S2. The moment you operate on S2, a closed here in S2 will give a 24 volt signal to a normally closed and make it normally open. And that makes the coil as well as lamp to get de-energized or go off. Okay, this is how the entire logic is implemented. Now just to go a little bit more into this, let's say I want to switch on the lamp after 10 seconds or after 30 seconds. That is when the timing things comes into picture. So we can as well insert timers here. So that's the next part of this discussion. So again, you can go back to this ladder programming part. You can go back to ladder programming, and you can see there ladder timers. There are too many different types of timers. We will concentrate on only timer on and timer off. So for the time being, we'll just take only timer on. Now what is our idea? Our idea is to switch on the lamp after, let's say, 10 seconds. And please remember, what we are doing here is a very simple logic, but the same concept can be applied elsewhere. Whenever you want to do any kind of automation process, the same concept can be extended to any kind of complicated process or program. So I have inserted something here. So you can observe I have inserted something called as a T on timer. I'll click on this. When I click it, when I double click on that, I hope all of you got to know how to insert this on timer. So you go to ladder diagram and you go to timers. You will see on timer there. Just click on that and place it here. Because my interest is to now turn on the lamp after 10 seconds. You will see how it happens. When you double click on the timers, you can see two things. One is timer reference. You can change this name at any time. The other thing is what amount of delay you want. So I just told after 10 seconds. As I cannot wait for 10 seconds, it's waste of time. Let me change it to 1 millisecond. So what will you do? You will write it as 1 milliseconds is anyways there and say OK. Now what is on timer is going to do? On timer means that if the high signal is given as input, to the input side, if you give a high signal, the timer will start ticking. Once the timer starts ticking, it will go on till whatever delay time that you have given. So the timer keeps on ticking till 1 second. The moment 1 second is completed, the output goes high on timer. So the output goes on after the elapsed preset time value. So preset time value in my case is 1 millisecond. And what will be the elapsed time? Once the timer starts ticking, starts from 0, goes up till 1 millisecond. So that becomes basically the elapsed time. So once the elapsed time and the preset time value, which is 1 millisecond in our case, they become same or equal, the output of the timer will go on. So that is what is called as on timer. So now we can understand what is off timer. So it's the reverse process. So once the elapsed time and the preset time value becomes same, output will go off. So that is basically off timer. Okay. So we will understand this on timer. If you want, I can just have it in a separate rank and understand what will happen. So probably that we can do. So what I will do is I will just try to have it in a separate rank. So I'll have a separate rung. I'll place this timer here. I'll try to have a contact. I'll try to use the same contact. I'll try to use the same X1. Okay. I'm using the same X1. So the moment I operate this push button here, the moment I try to operate. So as per the schedule, it's going to stop at 12 o'clock or 12:15. If you want me to extend a little bit more, I can do that. Or else, whatever you say. We will try to finish off this and wind up. Okay. So now what I've done is I've just tried to simulate only this timer part. So I'll run this quickly and see what will happen to on timer. So just see what happens. I'm pressing this first push button, S1. Observe what is happening to timer T1. You can see the timer ticking there. I'll just enlarge this so that you can observe what is happening. So please observe this timer T1, or you can as well do it on your system. You can see the timer ticking. Once it becomes 1 millisecond, you can see it's going green, which means that output went high. The moment I release the push button, I'm going to release it now. See what will happen to the status of the timer. Timer got reset. So the condition for this particular timer to be used here is you should keep the input always in the high state. Until and unless the input what you are giving to this timer is in the high state, timer will either tick or it will retain its state as in the sense, once the elapsed time and the reset time becomes same, the timer will be in the high state. The moment you disable the input, timer will also get reset. So what you can do now is we can insert this particular timer into this and see whether you are able to switch on the lamp after 1 millisecond or not. Let me reduce the time to 1 millisecond. Let me delete all these. So we will run this now. So what should happen? Once I press the push button and once I press the S1 push button and release it, the timer should start ticking after 1 millisecond. The lamp should glow. Let's see whether it happens or not. We have pressed it. Timer has started ticking now. All of you can see that as well. And did the output go high? You can actually copy. Output to that. Output to that. Taking this contacts to the next step. Inserting one more run here. Inserting one more run. Save this. Next slide. Let's see whether it works out. It should work. The whole logic is like this. So when you try to place basically a timer, the output of the timer will make the coil to go high, and the contact will get closed, and the lamp should go on after 1 millisecond. This thing should work. I do not know what is the problem in between. So this is how basically things are going to work. So there are too many things to really do here. 1 hour or 1.5 hours is really not enough for us to do all these, and we should really have kind of separate session that matter and understand from the PLC part how we can do all these things. So I think I've tried to give you a feel of the whole automation, or kind of how multisim can be used to develop the ladder programming thing. Even though I'm not able to do much in this 1.5 hours of time, I think I've done a little bit, and I hope you guys have got some input. Okay then. Thanks a lot. Thank you very much. I hope we're able to get something out of this. I got some feel of very basic automation. Very basic level of automation.
Thank you very much, Bhaskar.
Thank you, sir. Thank you so much.
dear participants, this is Ravi Kumar. Thank you very much. I hope we reach you a little bit about Labview as well multi-simulation. This is only the glimpse in this period of Corona. So this is only our motto to the thing is the technology never going to be end, and it has to be reached to everyone within all aspects. This is a new technology. We trying to be giving a glimpse about the Labview as well multi-simulation to you all. So with all this 5 days, we hope with our knowledgeable way we given you some of the information. Thank you very much. You given us very good support in all 5 days. And after this session, I'll post you the feedback form. Please fill it up, and after that, whatever all that 5 days contains with respect to all the examples as well notes, whatever the manuals, all the one we are sharing with you, and any aspects with Labview as well multisim, definitely contact us. We'll help you out in all regarding like as I know that installation problems some people are having, or some people are having with simulation part or something like any research oriented or any lab oriented or any training oriented or certification oriented. Please contact us. We'll help you in all the days, all the times. Thank you very much your support. Please fill up the feedback after this session. We are posting into your mail ID. Anything else, definitely will help you out. Okay. After putting your feedback, definitely will posted your whatever the certificate. Yeah, definitely I will send you the feedback link to you. In the feedback, I'm requesting you all. Please put your name properly as the name required in your certificate. Okay, because in the registration form I saw that so many people are made their email ID as a name, so I couldn't able to mention their names in the certificate. That's why please mention the name properly in your feedback form. The same name I can refer to make your e-certificate. Thank you very much, and thanks all of you are supporting me to complete my workshop of all 5 days. Any aspects with this, please let me know that anything you want to discuss or anything you want to ask respective to these 5 days workshop. Definitely, we are planning in such activities in further also. If the same COVID has continued the same, so in this vacation period, definitely we plan to do one more workshops with different platforms. Definitely, I'll communicate to you with the same your email ID. Please join and support us.
Sir, if you organize the antennas, hello?
Definitely, sir. In antenna related, some of our professors are there. Definitely, will encouraging those members. They are planning to that. I'll send the links to you people for the registration.
Actually, I am research scholar.
Okay. Thank you, sir. Thank you, Karnakar.
If any possible, we can start this as offline also, sir, in your college.
Yes, sir. We have the. Pardon, sir.
Yeah, better understood. You can conduct one more workshops are like this in offline.
Definitely, sir. Definitely, we are conducting. The situation gets settled down first. Then we planning for that. Every year we are planning the same thing for 5 days. So many people are coming and utilizing that our events. Definitely, we'll do that, sir.
Yes, sir, it will be helpful us for technically for getting
Yes,
some
hands-on definitely, because we have a lot of modules, so you can hands-on directly. So that will be helpful to you further your studies or the research.
so it will help for all the department better to connect for all the department technical stuff, sir. It will help for us.
Yes, sir. Yes, sir. We're planning, sir. Or any something like in your organization you want to do something, this kind of workshop. Please invite us. We'll help you out there. We can come to your place and we can do that. Whatever the workshop in your place, also we can do that. Because totally we are doing the same for in all the way. In all over Karnataka, we conducted a lot of workshop or the FTP programs in other colleges also, as well in industries also we have done. So please invite us. Definitely we'll make a plan with respect to your aspects.
Yeah, I will talk to our I will HOD for
Sorry to
will organize one, sir.
sorry to interfere. Sorry to interfere. Somebody is asking. Hello.
Yes, sir.
Hello. Sir, somebody is asking for an exclusive PLC thing. So the problem with the PLC is online teaching sometimes becomes really difficult until and unless we get to know the background of the participant. Kind of difficult for people to really work in the environment as far as PLC is concerned. So a lot of things are really involved dealing with PLC part. So it's good that if you're interested in PLC as well, probably we can as well conduct. We should start from the scratch. Until and unless we don't start from the scratch, it becomes very difficult for all the participants to understand things what is happening. So probably that is what is involved in PLC part. So it's good that few of you are eager to have PLC as well. And in electrical measurements also these things can be used. Multisim. So it has wide varieties of applications. Based on your interest, you can zero down to few topics as far as Multisim and Labview are concerned. And we can think of interfacing Labview as well as the Multisim together. And we can do a lot of things. Yes, sir. Anything could be done on Arduino, on kind of
Yes, sir. In all 5 days, probably we are just giving only. And go ahead with their. Thank you, sir. Thank you very much. Thank you very much.